Okay. Okay, 9. So I just wanted to quickly show you how to work with these complex shapes for those of you that were at cross country today. So um, you can take a look at these shapes in two different ways, right? You can either think about making multiple shapes and adding them together, right? So we could um, split this up, right? And then we would have this shape as one of our shapes, and our other shape could be this one, right? So we could split it up into two shapes. So if we did that, we'd have our two shapes, and we could just calculate the area by adding up the area of the two shapes. So we know that our total area, right, is going to be equal to the area of the purple shape plus the area of the blue shape. All right, so let's see if we can figure that out. Well, to calculate the area of the purple shape, I need to know my length and my width. Well, I know one of those is 9, but I don't know this one. So I can easily calculate that though, because I know that this whole length here is 10, and this little length here is 6. So that means that this distance must be 10 minus 6. So this shape, the distance, let's pull that back down, is going to be 10 minus 6, which equals 4. So that means then that this length right here is 4 centimeters. So now I can calculate the area of the purple shape because it's just going to be 9 times 4. So that's going to equal 9 times 4. And then to that, I'm going to add the area of the blue shape. So I know this side length is 6 and this side length is 2. So that's going to be 6 times 2, which is equal to 36 plus 12, which is equal to 48, or 48 centimeters squared. Don't forget your units. Okay, so now let's take another look at this shape, but now let's take a look at it as a subtraction question. So I'm just going to quickly redraw it. All right. So already from here, I still know this is 4 centimeters. I know this is 9 centimeters. I know this is 10 centimeters. I know this is 2 centimeters. And I know that this is 6 centimeters. So what I want to do this time is I want to think of this as a subtraction question. So I want to think of it as a bigger shape that I can find the area to take away a smaller shape. So to do that, um, what I'm going to do is I am going to extend, I'm going to extend this line right here and this one right here. All right, so if I can calculate the area of the big rectangle, and I can take away from it the area of the small rectangle, then I'm left with this bit. Okay, so if I can, so this is the area of the small rectangle. So when I've done the big rectangle, I subtract off the small rectangle, then I'll be left with the area of the shape. So let's give that a try. So the area then is going to be equal to the area of the black rectangle minus the area of the pink rectangle. So let's take a look at the area of the black. Well, I have a length and a width here. So I know that that's going to be 9 times 10. Okay, so it's going to be 9 times 10. And then I have, in the pink rectangle, I have a length here of 6, but I don't know what either of these sides are. But what I do know is that this is 9, so this whole side, and this small side is 2. So that means that this side right here has to be 9 minus 2, which is equal to 7. So this side length then is going to be 7 centimeters. So now I know if this is 6 and this is 7, then to find the area, I'm just going to multiply 7 by 6 or 6 by 7. And so that's going to equal 90 minus 42, which is equal to 48 centimeters squared. So whether you're adding or subtracting to find the area, so by taking a larger shape and getting rid of part of it, or putting two shapes together, you'll see that your answers should be exactly the same. So now what we want to do is we want to take that information and we want to use it to calculate the area of a composite shape where we're now using um, polynomials and we are no longer using numbers. But that what we're doing is going to be exactly the same. So the first thing we want to do is we want to split this up into two shapes if we're adding. So if we're adding, we're going to have this black shape, and then we're going to have this purple shape. So we know that the area in total is going to be the area of the black rectangle plus the area of the purple rectangle. And I know that the area of the black rectangle is just going to be the length times the width. So this 6x minus 1 times 2x. Now, we're dealing with polynomials here and monomials. So normally when you write a multiplication, there's a very specific way you have to write it. You would always write a monomial first. So it's going to be 2x. And now we want to take that 2x and we want to multiply it by this side length. And this side length is 6x minus 1. But it's an expression. So since it's an expression, we have to make sure that we put it into brackets. So we've now got 2x times 6x minus 1. To that, we want to add the purple. So we can pick either of the monomials because it doesn't matter. So 3x. And then to that, we want to multiply the 3x by the 5x, so we're going to put the 5x in brackets. If you remember back to grade 7 and 8, if you want to multiply things together, you can put them in brackets, and that indicates a multiplication. So now we just want to do the math on it. So we're going to take 2x times 6x, so 2 times 6 is 12, and x times x is x squared. And then we're going to take 2x and we're going to multiply it by negative 1. So negative 1 times 2 is negative 2x, and then there's nothing to multiply the x by, so it's just negative 2x. So now we're going to come over here and we have 3x times 5x, so 3 times 5 is positive 15, and x times x is x squared. So now I'm going to add up my like terms, so I have 12x squared plus 15x squared. Remember, when we're adding and subtracting, we just add the coefficients, but the variables stay the same. So 12 plus 15 is 27. So we have 27x squared. And then there are no other x's, so we have minus 2x. So that's adding the shape. So now let's see if that changes when we subtract the shape. So I'm actually going to draw the shape over here just because it'll make it a little bit easier to see what's going on. So I have my lovely shape, and I know that this is 2x, and I know that this whole side right here is 6x minus 1. Sorry about that. I know that this whole side right here is 3x and that this whole side right here is 5x. So I want to do this question just like I did on the previous page. So first I'm going to create a larger shape for which I can find the area. So I have this big black rectangle. And then from that I am going to subtract this smaller shape. Okay, so it's exactly the same. So my total area is equal to the area of the black shape minus the area of the pink shape. So in this case, the area of the black shape, well, I have this side length, which is 6x minus 1, but I don't know this side length, and I don't know this whole side length. But what I do know is that from here to here is 2x, and from here to here is 3x. So this side length has to be 2x plus 3x, which is equal to 5x. So this side length is 5x. So now I know that I have this side length is 6x minus 1, and this side length is 5x. So I'm going to multiply those two side lengths together. And like I said earlier, when I'm multiplying them together, I put the monomial first. So it's going to be 5x, and then I'm going to multiply that, and then the expression I'm going to put in brackets. Um, and I have to do this because if I don't do this, then it looks like it's just 5x times 6x and then just subtract 1, which isn't what is happening here. So now I want to look at the pink. Okay, so I know that this side length is 3x, but I don't know this side length or this side length. But what I do know is this whole thing is 6x minus 1, and this little part here is 5x. So this then has to be 6x minus 1 subtract 5x. Um, so that's going to be 6x minus 5x, which is 1x, and so I don't write the 1, and then subtract 1. So this side length then is x subtract 1. So this is x subtract 1, and this is x subtract 1. So now I know that when I look at the pink rectangle, one side is 3x and the other is x minus 1, so I just multiply them together, and again, you put the monomial first. So 5x times 6x is 30x squared. 5x times negative 1 is 5 times negative 1 is negative 5. And then x times, there are no other x's, so it's just x. Then we're going to do negative 3x times x. So I have negative 3, and x times x is x squared. And then I have negative 3x times negative 1. Well, negative 3 times negative 1 is positive 3, and then there are no other x's to multiply by, so positive 3x. And take note that here we're subtracting, right? And so I would expect that in this bracket right here, I have a positive and a negative, but down here I should have a negative and a positive, and then that makes sense. So now I'm going to collect and add my like terms. Well, I have 30x squared subtract 3x squared. So it's 30 subtract 3 is 27, and then my variable stays the same because this time I'm adding and subtracting. Then I have negative 5x plus 3x. Well, negative 5 plus 3 is negative 2, so I have negative 2 of these x's. And so hopefully what you can see is my expressions that represent the area are the same. 27x squared minus 2x and 27x squared minus 2x. So what I want you to do then is to finish questions 3 and for question 3, since you're doing this by yourself, make sure you do both the partner A and the partner B parts to get the right answer. And then you can finish pages 4 and 5. Hope that helps. If you have any questions, come and see me.